Hello, everyone. So here we'll look at solutions to quiz 3 of Pre-AMC. All right, so let's look at problem number 1. So problem number 1 says there are 8 consecutive integers if we know the sum of the first 3 is 63, and we need to find the largest number in the list. Okay, so first of all, solution. All right, so we say, so here is we look at the first 3 numbers consecutive. All right, and we know their sum, if you add up, is 63. Well, we know if the middle one is a, and then this is just a plus 1, and this a minus 1. So if you add them up, add this, it's just 3 copies of the middle one, right? All right, so from here, we quickly get the middle one, a is 21, right? So which is 63 divided by 3. All right, so we have the list. So this is 21, and this is 20, and this is 22, and all the way to the 8th number, so the largest one. So clearly, the largest one, this will be 27. So here we just use the fact that if I have 3 consecutive integers, then the sum is just 3 times of the middle one, right? Which is clear. All right. Okay, so now let's look at the problem number 2. The problem number 2 says, this year Joshua is 10 years old and his father is 43 years old. Now, after some years, his father's age becomes 3 times Joshua's age. So we need to figure out like after how many years. Okay, so there are 2 ways to solve this problem. So one way is without algebra. So method 1. Method 1 is no algebra. Right, if we don't use algebra, which means we are not going to introduce variable x and then set up equation. Now, if we do not do that, then the key observation is there's one number that does not change after time goes on. That is the age difference. Okay, so the key is the age difference between Joshua and his father does not change. Does not change. Right? Because every year, if Joshua increased one year, and his father also increased by 1 year. So the difference does not change. Okay, so what is the difference? We know the difference is just 42 minus 10, which is 32. Okay, so start, we have 10, and this is 42, right? So this is Joshua, and this is his father. Now, after several years, the age of Joshua, okay, so the age of his father is 3 times of Joshua. So this 3 times. So this is the age of the father. Now, because the age difference does not change, right? So the age difference here is 32. And this also should be 32. Does not change. Okay, so that means each one here will be 16, 16, 16, and 16. All right, so then we know it's go from 10 to 16. So it's 6 years, right? So it's 6 years after 6 years. So here we don't use any algebra. The key is the age difference does not change. All right. Okay. So this is method 1. Now let's look at method 2. Let's use algebra. And you see, the advantage of algebra is we don't have to be smart because there's a robust procedure to solve this kind of things. Now, the method without algebra, the one we just presented, is you have to kind of clever to realize the age difference does not change, right? Okay, so now we look at method 2. Method 2 is with algebra. Okay, so this is kind of robust, all right? So what I do is I just introduce a variable. I say it's f, so x is, say it's f x years, or after x years. And this is what we need to figure out. All right, so Joshua started from 10. His father is 42. Now after x years, after plus, which is plus x, then Joshua becomes 10 plus x, and his father becomes 42 plus x, right? You see, so there's no trick here, everything's very standard. Now we just use the condition. His father's age is 3 times of Joshua's age. Okay, so by this, we get a 42 plus x is 3 times of 10 plus x, right? Okay, so we get equation. So that's the point. We introduce variable and we get equation. All right, so this one is just a 30 plus 3x, so 3 times 10 and 3 times x. Okay, we get 42 plus x with that. And from here, you solve 12 equals to 2x, right? Because you just move x. So this is 1x, this 3x, you move to the other side. So we get x equals 6, right? Okay, so this is how we solve this one by using algebras. Okay? All right. Now let's do problem number 3. Okay, so problem number 3 says we have a 7-digit number. So it's 1, 2, 3, 4, 5, 6, 7. And we know the number consists of either 2 or 3, and there are more 2's than 3, and it's divisible by 3 and 4. Right, so then we need to recall those divisibility tests for 3 and 4. Well, for 4, we know a number is divisible by 4, you only need to look at the last 2 digits, right? Okay, so for divisibility test for 4 is we look at the last 2 digits. Okay, so that means we look at the last 2. Now, because here we only have 2 and 3, so the only way we make it to be divisible by 4 is 32, right? So then we get this one clear. So this is 3 and 2. All right, so now we just need to see how should we put numbers for the remaining 5, okay? And here, for that, we use the divisibility test for 3, right? So for that is we look at the sum of digits. Should be divisible by 3. Okay, so a number is divisible by 3 if and only if the sum of digits is divisible by 3. All right, so for that, you see, and we can try, you see, if you look at, because you only have 2 and 3, I need to find the only option that works is 2, 2, 2, 2, 2, and then this is 3, 2. Now for this one, of course, if you add those digits together, it's okay, I add them together, right? I add 3 and plus 2, right? So this is 15, right? So this is 15, so which is divisible by 3. Now, if you just care about divisible by 3, so there are other options, right? So one way you can do is, okay, how about, you say, well, how about 2, oops. You can also do 2, 2, okay, so you say 3, 3, 3, 3, 3, all right? So this one is also divisible by 3, so if you add the digit together, right? But nevertheless, for this one, violates the requirement here. There are more 2 than 3 in the end, so which is this one is not valid. All right, so the conclusion is if you combine all those requirements together, this is the only one that works. Now, so you just need to figure out what is the remainder, right? So you say, okay, I just use this one, so this 2, 2, 2, 2, 2, 3, 2, and then you divide by 7, and you figure out the remainder. And this is, you see, it's very easy to figure out. The remainder is 5. So the key point is you need to figure out what is the number. And here, the 2 main points is we need to consider the divisibility test. So let me repeat. A number is divisible by 4. You just look at the last 2 digits. They should be divisible by 4. A number is divisible by 3. You just look at the sum of digits. The sum of the digits should be divisible by 3. So those divisibility tests, they provide shortcuts to tell whether a number is divisible by certain integers. Okay. All right, now let's problem number 4. So number 4 says, according to a rule in a violin computation, the preliminary round has 4 rounds, individual rounds, and you have to, in order to enter the finals, the average score of those 4 rounds has to be no less than 96, right? Okay, so here's actually scores in those first 3 is 95, 97, and 94. The question is, okay, so what is the minimum score she needs to get for the last one in order to enter the final? So which means the average should be no less than 96. All right, so average no less than 6, what does that mean? Okay, so we translate this into a solution. we translated this into the definition of average. So it just means 95.97 plus 94 plus this question mark. There should be no less than 96 multiplied by 4, right? Multiplied by 4, because average is divided by 4. Okay, so let's calculate this number. So this number is 384, okay? And then we have the question mark is at least. At least. You have 384 and minus 95 minus 97 minus 94, right? So it's 384 minus this four numbers. We can calculate, which is 320 plus, which is 16. So it's together, right? So 284, 86. All right. So then when you do the calculation, you get this is 98, right? 98. Okay. So we get at least she needs to get 98 in the last round in order to be qualified for the final. So here we just this one just tests the basic concept of average. Right? Okay. All right. Problem number 5. There's a haunted house. It has a haunted house that it has 8 windows. Okay, so and the other requirement is the ghost, right? George, the ghost. He buys this rule. So he enters the house by one window, then leaves by a different window. The question, how many different ways can he do that? All right. So here we have 8 windows, right? So this is the multiplication principle, as it put in the hint. Okay, so what we use is the multiplication principle. So as we said before, the multiplication principle says, if you want to accomplish your mission, if the mission has several steps, if you have multiple choices for each step, then the total number of ways you can finish the mission is you do the multiplication. So here we have 2 steps. Step 1 is choose the entering window, right? Window, okay? So from where George the ghost enter the house. And then, so here you have, obviously you have 8 choices because you can choose any of these 8 windows to enter the house. Now step 2, choose the exiting window, right? All right, so that's one restriction. He cannot choose any window he likes. The requirement he has to exit by a different window. So if this one is the entry window, then get out has to be on a different window, right? Has to be on a different window. You can choose any of these 7 remaining one. All right. So it has 7 different choices to get out of. When the point is when the entry window is selected, then in order to get out of it, there are several different choices. So by the multiplication principle, the total number, the number of ways is multiplication is 8 multiplied by 7, which is 56. So that's why we call the multiplication principle. We do not do addition, we do multiplication, right? Right. Since each entering window is associated with 7 different choice of exiting window, right? So that's why it's 8 multiplied by 7. All right. Okay. All right. Problem number 6. So the problem says that Jackie bought a bottle of alcohol from the pharmacy to make homemade disinfectant spray. Okay, so then he wants to dilute the alcohol by adding more water. So the question is, okay, how much? What is the amount of water that he needs to add in order to reduce the percentage of the alcohol from 90% to 75%? So here, what is the key? The key is during this process, there's one thing that does not change. That is the amount of alcohol, right? Okay. So solution. So initially, so this initially is 90%. So let me put this. It's 90%. 90% is alcohol. In total is 30, right? So that means it's 30 times 90%. 90%, this one is just 9/10, right? So this 9/10 times 30, which is 27. So initially there are 27 alcohol. So it's 3, this is the water. Okay? So this is alcohol, oops. All right, now he added more water into the bottle. All right, okay, so the number of, as I said, the number of alcohol does not change. It's still 27. Okay, so here's the key. So let me sum, the key is the amount of alcohol does not change, right? So that's the key. All right, now this time, this one becomes 75%, right? It's 75%, which is, if we change this one to fractions, this is 3/43. That means, oops. All right, so that means this will be 1/4. The water will be 1/4. Well, this is 3 portion. This is 1 portion. So we get the water becomes 9, right? So this is 9. So because 9 is 27 divided by 3. All right, so this is the 9. Okay, so the water is 9. So this is the amount of water. So water go from 3 to 9, so it's at 6. So that's why we put a 6. All right, so for this problem, as I said, the key is, keep in mind, the amount of alcohol does not change. So if from the first one, we figure out the amount of alcohol is 27 ounces, and the next one is still 27 ounces. Now use that information, we are able to figure out the number of water, right? Because one is, for this new one, this is the alcohol is 3/4, water is 1/4. So water is 1/3 of alcohol, that's 9, okay? All right, number 7. So here we have, we start from a rectangle paper and we cut 2 squares in this way. The question is, we need to find what's the parameter of the remaining part. So let's trace the parameter of the remaining part. So we have that, and go this, go that, go that, go that, go that, right? So this is the remaining part. So we trace its boundary right here. All right, okay. Now, so let's observe this. So if I use this part, this part, this part, this part put together, these 3 put together, I can feel this one, right? I can feel this to that, to that, to that, okay? So that means I can erase this part. I can erase this 4. All right, so then what you have is, and we have remaining is this, which is 12, and this is 4. So it basically becomes 12, 12, 4, 4, and plus the parameter of the whole bigger rectangle. Okay, so then we have the parameter. So solution equals to 50 times 20, which times 2. So this is the rectangle. And then plus 12 times 2, and then plus 4 times 2. So let's see what we get, right? So we get is 140. So this is 140, and then plus 24 plus 8. Okay, so then this is 172. All right, so then we get the parameter of the remaining part is 172. So as I said, so here the main trick is we realize so this piece, and this piece, these 3 pieces, if I push up, right? If I push up, it will exactly fill the missing pieces here, right? Exactly fill the missing pieces here. So if I add it back, then combined with the remaining red ones, what I get is exactly the parameter of this big rectangle. Okay, so then you just add 2 vertical ones and these 2 small vertical ones, and that gives you the parameter of the new thing.